Welcome back to General Chemistry mini lecture series. Today we are going to go over quantum numbers and electron orbitals. So first we are going to talk about the quantum mechanical model of the atom. So here we are going to use the Schrödinger equation H psi equals E psi here, so to describe electrons and electron orbitals. Okay, and H here is the so-called Hamiltonian operator, so you can learn more about that if you are interested in that. And E is simply the energy, and psi here is the wave function. Okay. If we apply certain restrictions, actually those restrictions are related to the quantum numbers we are going to talk about, then the electron can be found in discrete regions called orbitals with a very high probability. Again, an orbital is described by restricting it to a set of 3 quantum numbers. Okay, what are the 3 quantum numbers? Principal quantum number, actually, that describes the energy level and energy shell. Angular momentum quantum number, L, that actually describes the energy subshells and also the shape of orbitals. Magnetic quantum number ML, it describes the orientation of orbitals in the 3D space. Well, orbitals are described by 3 quantum numbers. Electrons actually can be described by 4 quantum numbers. For a given electron, it can be described by the principal quantum number N, angular momentum quantum number L, magnetic quantum number ML, plus spin quantum number MS. Now, the principal quantum number N, and sometimes we call that principal energy quantum number. Okay, so the allowed values or restrictions for N is N can be 1, 2, 3, 4, and so on and so forth, positive integers. Okay, so that's the restrictions or allowed values for principal quantum number. Basically, it represents energy levels, electron shells, as well as the periods in periodic table. Okay, so energy levels, that's the nucleus, and then do you see this one, this circle? That's the N equals 1 energy shell. Then the second one, that's the second level. N equals 3 is the third level, N equals 4, the fourth level. Later on, we are going to learn actually N equals 1, we call that K shell. N equals 2, we call that L shell. And then M for N equals 3 and N for N equals 4. Okay? And here again, you see N equals 1, we call that the first energy level or first energy shell, second, third, and fourth. What are those numbers? Those are the maximum number of electrons. The innermost can only accommodate 2 electrons. And N equals 2, that energy shell or energy level, maximum 8. The third one, 18. The fourth one, 32. We will discuss more about this in the future lectures. Okay, those are the electron shells. Okay, So N means electron shells or electron levels. Okay. And there's another way to represent the energy levels. Okay, you can see here N equals 1. That's this first circle. N equals 2, the second, and then 3, 4, 5, 6, 7. Okay, so that's what we're talking about. N represents energy levels or electron shells. And then N equals 1, 2, 3, 4, 5, 6, 7. That also represents the number of periods. Okay, so the first one, hydrogen, helium, N equals 1. So the first period. And then the fifth period right here, N equals 5. Angular momentum quantum number L. The allowed values for L is 0, always starts from 0, 1, 2, and the maximum is N minus 1. So it cannot be greater than N minus 1. So therefore L is independent. Angular momentum quantum number represents the electron subshells as well as the type and shape of orbitals. So I wrote down here 4 types of orbitals, but there are more than that. So, but we'll start with these 4. If L equals 0, that's S subshell or S orbital. L equals 1, that's P orbital. 2, that's D. And if L equals 3, that's F orbitals. Okay, so now let's take a look at the shape. If L equals 0, the S orbital is spherical. L equals 1, the P orbital, that's 2 lobes. L equals 2, then D orbitals, that's mostly 4 lobes. And then when L equals 3, that's the F orbital, mostly 8 lobes here. So we can only see probably 6, but mostly should be 8 lobes. Okay, and now as we can see, these are the shells, energy shells, or energy levels. Or we can say the principal quantum number for here, that's equals 1. So N equals 1 energy level, N equals 2, N equals 3. So those are the main shells, we can call that, okay? And then the quantum number L is responsible for those subshells. So L equals 0, that's the S subshell, S subshell, 2S, 3S, 4S, and so on and so forth. L equals 1, P subshells, and then we also have D and F subshells depending on the L values. Okay, those values are the number of orbitals. So here 1 means there is only 1 S orbital, and for P orbitals, there are always 3 P orbitals, and for D, always 5 orbitals, for F subshell, always 7 orbitals. And those, the number of orbitals, they are determined actually by magnetic quantum number, ML. And the allowed values for ML is from negative L to 0, then to positive L. Or in other words, the other way of stating it is ML equals 0, plus minus 1, plus minus 2, until plus minus L. So ML is L dependent. As I just mentioned earlier, so ML represents the number of orbitals in each subshell, as well as the orbital orientation in space. Yeah, let's bring this set of orbitals here again. when L equals 0, then ML can only be 0 based on the rules here. Alright, so therefore there is only one s orbital. So therefore there is only one s orbital because there is only one ML value. So that's the s orbital spherical. But if L equals 1, then there are 3 ML values. Alright, 0 plus minus 1, and since L is 1, so therefore we have to stop right here. But there are 3 ML values, which means there are 3 p orbitals. So this is the px. So the orientation of the orbital is along the x-axis, and this is py. The orbital is aligned with the y-axis, and this is the pz. You see, so there are 3 p orbitals. When L equals 2, then there are actually 5 ML values according to the rules. So therefore, there are 5 d orbitals. Okay, so L equals 2, that's the d subshell. So d subshell always have 5 orbitals. L equals 3, then there are 7. 0 plus minus 1 plus minus 2 plus minus 3. That's a total of 7 ML values. Therefore, 7 f orbitals. Now the last quantum number, spin quantum number, ms, it can only have 2 allowed values, either positive 1/2 or negative 1/2. We normally use arrow up for positive 1/2, arrow down for negative 1/2. So it's really the 1/2, that value really doesn't mean anything mathematically. It just means the spin direction of the electrons, okay? So one clockwise, let's say, the other one counterclockwise. Now let's take a look at the hierarchy of quantum numbers. So electron shells, okay, so that's the principal quantum number, energy level or electron shells. So they are described by only one quantum number. So that's just n. However, subshells or energy sublevels or sub-energy levels that are described by 2 quantum numbers, n and l. For example, the 2s subshell, it means n equals 2 and l equals 0. The orbitals, however, are described by 3 quantum numbers. What are the 3 quantum numbers? N, L, and ML. N, L, and ML. For example, 2py. 2 means n equals 2, p means l equals 1, and y is one of the 3 ML values in p subshell, indicating the orientation of this specific orbital in space. It means, in this case, py, it means the orientation of the 2 lobes or the orbitals is aligned with the y-axis. Okay, so orbitals are described by n, l, ml, 3 quantum numbers. However, electrons are described by all 4 quantum numbers, n, l, ml, and ms. Pauli exclusion principle states that no 2 electrons in an atom may have the same set of 4 quantum numbers. One orbital may have a maximum of 2 electrons, and the 2 electrons must have opposite spins because no 2 electrons can have the same set of 4 quantum numbers, so cannot be exactly the same. Okay, that's why each orbital can only accommodate 2 electrons. Okay, so using those rules, especially using the Pauli exclusion principle, ice subshell, we know it has only 1 orbital, so therefore it can only hold maximum 2 electrons. P, 3 orbitals, then can hold maximum of 6 electrons. D, 5 orbitals, maximum 10 electrons. F, subshell, 7 orbitals, maximum 14 electrons. If you recall this figure from previous slides, so remember those values, those are the maximum number of electrons. Okay, so now let's take a look. Okay, when n equals 1, then L equals 0. There should be only 1 orbital, and that is 1 s orbital. Okay, so if it's an s orbital, maximum can only hold 2 electrons. And since there is only 1 orbital right here for n equals 1, so therefore maximum 2 electrons. Then if n equals 2, look at that. If n equals 2, there are 2 subshells. One is 2s with 1 orbital. The other one is with 2p, 3 orbitals. A total of 4 orbitals. 4 times 2, then 8 electrons maximum. N equals 3, there are 1 orbital plus 4 plus 5. That's a total of 9 orbitals for n equals 3, which is the 3rd orbital right here. 9 times 2, that's 18. And you can do the same for the 4th, 5th, and 6th, and so on and so forth. Okay? Now let's work on a few examples. The first one, what values are possible for L when n equals 3? And we know the rules for the allowed values for L is starting from 0 until maximum n minus 1. Since n equals 3, n minus 1 is 2. So therefore 2 should be the maximum. Then 1, 0. So therefore the possible values for L is 0, 1, 2. Example 2. Find out what is sets of 3 quantum numbers N, L, ML for the 4th energy level. 4th energy level, it means N equals 4, the principal quantum number N equals 4. If N equals 4, then L can be 0, 1, 2, all the way to n minus 1. N equals 4, 4 minus 1, that's 3. So therefore, L equals 0, 1, 2, 3. Then the ML values are dependent upon the L values. So ML equals 0, plus minus 1, plus minus 2, until plus minus L. When L equals 0, and of course is 4, then ML can only be 0. So there's one side of 3 quantum numbers, or 1 orbital. N equals 4, L equals 1, then ML value can be 0, plus, minus 1. That's 3 sides. And to be specific, what are those 3 sides? So they are n equals 4, l equals 1, ml equals -1. The second one, ml equals 0. The third one, ml equals +1. So those are the 3 specific sides here for n equals 4, l equals 1. Next one, let's take a look. L equals 2. L equals 2, then ml can be 0, plus or minus 1, plus minus 2. That's 5 sides. L equals 3, then ml has 7 values, 0, plus minus 1, plus minus 2, plus minus 3. That's 7 sides. If you add all of those together, that's 1 plus 3, that's 4, plus 5, that's 9, plus 7, that's 16. A total of 16 sides of the 3 quantum numbers, and that's actually 16 orbitals. 16 orbitals for the 4th energy level. Example 3. Find out all possible sides of quantum numbers describing an electron in a 3p orbital. What does 3p mean? 3 means n equals 3. P means L equals 1. Alright? Okay? So if L equals 1, there are 3 possibilities for ML values, 0, plus, minus 1. And then let's take a look at those orbitals. So remember, the orbitals are described by 3 quantum numbers, N, L, and ML values. Okay, the first one, N equals 3, L equals 1, ML equals -1. And then the second orbital, ML equals 0. The third orbital, ML equals 1. Those are the orbitals. How about electrons? Remember, electrons are described using a set of 4 quantum numbers. So those 3 quantum numbers, N, L, ML, plus the spin quantum number, ms. Okay, so for this orbital, we can have the 4 quantum numbers can be the first 3, they have to be the same. 3, n equals 3, l equals 1, ml equals -1. It's only the last quantum number, it differs. You see, the first 3, they are all the same. But for the first electron, ms is +1/2. For the second one, ms is -1/2. And the same is true for ml equals 0. Okay, so only differs by the very last quantum number, ms. And then also for ml equals 1, the 2 sides of quantum numbers for the 2 electrons, the first 3 quantum numbers are exactly the same. So only the last one, ms, they are different. So just a quick recap. Orbitals are described by 3 quantum numbers, N, L, ML. Electrons are described by 4 quantum numbers, N, L, ML, and ms. Here is the first end of lecture quizzes. What values are possible for L when n equals 4? Okay, when n equals 4, the L value can only be 0, 1, 2, 3. Should we keep writing 4? No, because the allowed values for L, the maximum, is n minus 1. N is 4, 4 minus 1 is 3. So therefore, this should be the correct answer, this side. So which is a C. Now you need to work on the remaining quiz questions here, as well as homework assignments. I will see you in the next lecture.